Uh, Last time we have completed
Sir, we completed the
st-
the the
states of
cooling.
matter, right? Cooling
Yes, sir.
curve and heating curve. So today is your lecture number 3, right?
Yes,
So
sir.
yesterday we have discussed cooling curve. We have discussed effect of impurity on boiling point and melting point, right? So here we have started lecture number 2. So first we discuss the change of state, how solid convert into liquid and liquid convert into steam. Similarly, liquid may convert into solid, and solid may convert into gas. Then we discuss melting point. Then we discuss effect of impurity on melting point. Yes, can anyone tell me what is the effect of impurity on melting point? Either it increases or decreases.
Sir, it decreases as the impurity increases.
Okay, impurity decreases the melting point. Now boiling
Yes,
point.
sir.
So we discuss boiling
Sir,
point
for
and
the
then
boiling
effect.
point,
Hmm. Yes.
no, sir. For the boiling point, is it increases the boiling point.
Okay, increases the boiling point. Right. So then we have discussed few DIs, right? Doctor instructions. So if melting point and boiling point both are lesser than boiling room temperature, then it would be
A gas, sir.
Gas, sir.
a gas. If both are greater than room temperature, then the state of matter would be
Solid, sir.
Us.
solid. If boiling melting point is lesser and boiling point is high, then
Sir, it would be a solid. No, liquid. Gas, gas, gas. Which one,
liquid.
sir? Can you repeat the question?
Okay. If its melting point is lower than room temperature and boiling point is greater than room temperature,
Sir, it's liquid.
it's liquid, right? Then we discuss cooling and heating curve. This is the keys to memorize, and this is the cooling curve, right? So today our topic is diffusion, right? Before going to diffusion, uh, okay, diffusion. So can you tell me what is diffusion?
So, sir, diffusion is like the movement of particles from a high concentration place to a low concentration place.
Okay. Yes, Bete, what is diffusion?
Sir, diffusion is when you it's like when gas particles they travel from a high concentrated place to a low concentrated place. Like for example,
Hmm.
like when you put on perfume, then all the gas particle and then the smell um, comes in the whole room. This is because the particles travel to the low concentrated areas where those
Hmm.
typical gas particles aren't there.
Yes. So today first point, right? It is a process. It is a process of random motion of molecules. Either molecules belong to liquid, either molecules belong to gas, by which there is net flow of matter from the region of high concentration to a region of low concentration. Low concentration. Yes, can anyone give me the example?
Sir, like for example, the perfume example, like when you put on
Example,
perfume.
yes, perfume of a flower.
Sir, I have another example.
Yes,
So like the smell of food.
exactly. Especially smell of biryani. It is very difficult to hide the smell of the biryani. Perfume of a flower that quickly is spread in air.
Sir,
Example number two, yes.
sir, you said matter, so it's not like important. Like it's not necessary that it's only gas particles, right? It can even be solid particles. Like for
It is
example,
very difficult to for solid particle, right? Because solid particle vibrate, they do not move, right? So less chances of diffusion. But in a liquid, if some particles are dissolved and their size is very smaller, then these particle can be moved from the concentration of high concentration to lower concentration. Are you getting my point?
okay, sir.
This is diffusion. This is diffusion. Now look at here. Here you have high concentration of these particle. High concentration. Here we have low concentration of particle. Low concentration of the particle. So these particles move. So particles move. Movement. Beta, are you getting this point?
Yes, sir.
Yes, sir.
Okay, Alhamdulillah. So basically, diffusion is the movement of molecule from a region of high concentration to the region of low concentration. Now, next is liquid and gases undergo diffusion. Undergo diffusion as molecules are able to move randomly. There is no movement of particle. There is no movement of particle in solid. Now look at the example. Here you have water. Here you have water molecule. Now I poured ink in it. This is the dropper. This is dropper. So this ink is dropped in it. These are water molecule. So these are water molecule. These are dye molecule. Dye molecule. Now you can see that movement of molecule increases. Now you can easily see a spread of molecule. Now you have equilibrium in it. This is equilibrium. This is 1, this is 2, this is 3. Movement of particles. Movement of particles. Yes, do you have any question?
Sir, what is equilibrium again in the
Equilibrium means the equilibrium, it means number of uh, water molecule equal to the number of dye molecule, right? So spreading of dye is uniform. This state is called equilibrium state.
Okay.
Are you getting my point or not?
I get it.
Okay, Alhamdulillah. Now, factors affect the diffusion. Next is factors affecting diffusion. Factors affecting diffusion. Factors affecting diffusion. So rate of diffusion depends on certain factor. Rate of diffusion depends on different factor. Yes, name these factor. Yes,
Sir, first maybe it's temperature
first is temperature, correct?
and also the surface area of the container.
surface area of the container,
Sir,
or
surface area.
size of the particle. Or you can say that
Sir,
area of interaction, right?
yes, sir.
Area of
Sir,
interaction,
what
right?
about yes, pressure?
Pressure.
Yes, like
Okay.
how much the pressure is between the solute and solvent.
No, this is called attraction, right? But whenever you increase for the gases, if you increase the pressure, so let's see what will be the effect, right? We will discuss later, right? Area of interaction, size of the particle being is diffused, size of particles. Next is,
Sir,
yes,
can we say distance?
yes, stiffness of the concentration. This
Oh,
is
okay.
called concentration gradient. Concentration gradient. Okay. So with the next is, mm, yes, can you tell me when you increase the pressure, rate of diffusion increases or decreases?
Sir, it increases.
It increases. Okay. So it means you know the effect of temperature, right?
Yes, sir.
So no need to write more things in it. Now the next topic is, next topic from the syllabus is effect of, describe the effect of temperature and pressure on the volume of the gas. Now next topic from the syllabus is effect of temperature and pressure on the volume of the gas. Yes. And can anyone explain this statement? Effect of temperature.
Sir.
Yes, Vijay.
This basically means that how does temperature affect the volume, like how much space it occupies for a gas? How does
Yes.
temperature and pressure as well?
Yes, exactly. Both. First discuss the temperature and then discuss the pressure.
Yes, sir. So should I tell it?
Yes, yes.
Okay. So basically, as the temperature increases,
Hmm.
so the gas particles they expand, and then so the volume of the gas it increases.
Okay.
And then we can say about the pressure that as the pressure increases, the volume also increases because then there are more collisions.
Hmm. Very good. Very good. Yes, very good answer. Yes. Anyone? Now you, my second student, Can you explain this effect?
Yes, sir. So basically, it means like with the temperature, it gives more heat to the particles, and so they push off and like they move away from each other, and so the volume
Mhm.
increases. That's why if the temperature increases.
Okay. Now, first statement is volume of the gas is directly proportional directly proportional to its temperature. Can you tell me what is directly proportion means? Yes. What is the directly proportional means?
Sir, it means that if the temperature increases, then the volume of the gas also increases along with it.
Yes, exactly. It means when you increase the temperature, volume also increases. When you decrease the temperature, volume also decreases. So both are directly proportional. Do you know the meaning of this mark?
It means directly proportional.
Directly proportional. Now, next is temperature. After temperature, pressure. Yes. Can you tell me the effect? Volume of the gas is directly or inversely proportional to its pressure. Yes. When you increase the pressure, particle come closer. So volume decreases.
Yes, sir.
So inversely proportional. So whenever you show the inversely relationship, you have to keep it in denominator. So 1 over P. So 1 over P indicates inversely, without 1 indicates it's directly. Are you getting my point or not?
Yes, sir.
Sir,
Now
so
look at,
for invest in
yes,
so sir, so can you go up?
yes, tell me, yes,
No, can you go up?
yes, yes, yes.
So for so inversely proportional, meaning like you have to show both signs, the first the direct proportional sign, and also the I over P, right?
This is 1 over P. 1 over P means inversely, and without 1, this is called reciprocal, right? This is called reciprocal. Whenever you have reciprocal, it means inversely. Without reciprocal, it means directly.
Okay.
Are you getting my point, bete?
Yes, sir.
Okay. Now look at the example. Let's suppose you have this container and here you have piston. This is piston. Here you have fire. Here you have fire. So now look it again. Now let's suppose here you have gas particle, right? These are the gas particle. When you increase the temperature, gas particles expand. Now you can see that volume increases. This is volume V1. Here you have volume V2. This is called volume V1. This is called volume V2. This is called volume V2. So when you increase the temperature, here you have more temperature. Here temperature is T1. T1. But here you have temperature T2. Here you have temperature T2. Now you can see that when you increase the temperature, volume also increases. Are you getting my point?
Yes, sir.
So this is volume is directly proportional to T. This law is called Charles law. This law is called Charles law. Whenever you increase the temperature, volume increases. Volume increases.
Yes, sir.
This is effect of temperature. Effect of temperature. This is called effect of temperature. Now effect of volume. Effect of pressure on volume. Now effect of pressure. Now this is case number 1. Here temperature is constant. Let's suppose here you have only one pressure. This is pressure. Let's suppose this is pressure P1. This is pressure P1. At this pressure, volume is V1. Now, when you increase the pressure, now let's suppose you have exerted more pressure. This is pressure P2. Here volume is V1, here volume is V2. So when you increase the pressure, volume decreases. Are you getting my point or not?
Yes, sir.
Yes, sir.
Now volume is inversely proportional to pressure. So when you increase the pressure, volume decreases. When you increase the pressure of the gas, volume of the gas decreases. When you increase the pressure, volume of the gas decreases. Similarly, when you increase temperature of the gas, volume of the gas increases. Volume of the gas increases. Are you getting my point?
Yes, sir.
Yes, sir.
This is called, these are called Charles law and Boyle's law.
Sir, the second one was which law?
Boyle's law, Boyle's law. I'm
Boyle's.
writing the name. I'm writing the name. This is called Boyle's law. Boyle's law. Volume is inversely proportional to pressure. This is called Boyle's law.
Okay, sir.
This is called Boyle's law. Now, in the syllabus, you have same thing, but according to kinetic molecular theory. But according to kinetic theory. Now, you can see the syllabus. Yes. 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 Number 6 is explain term of kinetic theory, the effect of temperature and pressure on the volume in term of kinetic molecular theory. So next topic is in term of kinetic molecular theory, effect of temperature and pressure on volume of the gas. Volume of the gas. Yes. Do you know what is kinetic molecular theory? Says
Yes, sir.
about the, yes.
It means the movement of molecules of a substance.
Mhm. Yes. So why when you increase the temperature, volume increases?
So, sir, for it, why when you increase, if you take in the kinetic molecular theory, then it's
Mhm.
basically like, for example, if you increase the temperature, then the
Hmm.
particles get more energy and they vibrate more. So basically, then they push off and bump into each other more frequently, and so they bump, and then they get further away from each other. And so as
Hmm.
the volume increases, so
Okay.
just like, for example, how the liquid turns into gas as you give in temperature, right? So the particles get further away from each other and they become gas, right? So
Hmm.
and gas only, now when you give more heat, then volume of the gas increases instead of changing into another state.
Hmm. Very good. Very good. Yes. Can you second one, other student, can you explain the effect of uh, increasing temperature and pressure according to the kinetic molecular theory?
Sir, so basically, if when the temperature increases, the gas particles they get more energy, and they get more heat, and then they get more energy, and then they start to move faster. And then because they start to move so
Hmm.
fast, the bonds between them they break further, and then they move away from each other. So the volume increases. And then for
Hmm.
pressure, when pressure is given to the gas, then
Hmm.
the area between the particles, it reduces. So basically
Hmm.
the pressure, so the volume of the gas, it decreases.
Very good. Now, first effect of temperature, right?
Yes, sir.
First, so as you know that the name of the law is Boyle's law. So Boyle's law and kinetic molecular theory, KMT. Boyle's law and Boyle's law means
So
effect
Boyle's
of
law was for
hmm,
Boyle's law was for pressure, right?
yes, exactly, effect of pressure on volume. So you know that gases can be compressed because most of the volume of the gas is empty. So when you increase the pressure, this space is filled and the volume of the gas decreases. Are you getting my point or not?
Yes, sir.
Yes, sir.
So point number one, point number one, gases can be compressed because most of the volume of a gas is empty space. Point number
What?
two, yes,
So if there are empty spaces between the gas particles, right? So but what
exactly.
happens? So what happens if the empty space in the gas it replenishes? There isn't any empty space in the gas, and you're keeping on keeping more pressure on the
Yes,
gas
when
particles.
yes, exactly.
Then
When you increase the pressure, the distance between the gas particle decreases. So they come closer. So volume decreases.
so when there isn't any empty space between the particles, then
It,
will the volume decrease more further
yes, yes,
or not?
yes. Exactly. It decreases more. You
How
can
about
you
if
can
there is
you can
any empty
observe the
space?
change. When you compress the gas, change is very big. But when you compress the liquid, change is very small. Why? It indicates that gas particles have more space between them. There is a lot of space between the gas particle. That's why when you compress the gas, volume decreases more as compared to liquid. And there is no space between the solid particles. That's why when you compress the solid, it would remain same. No change in volume. Are you getting my point or not?
Okay. So, but sir, if you compress to a point where the empty space finishes, there isn't any empty space left. If you
So it
compress so
so
much.
yes, if you compress so much, gases become liquefied. Why they liquefy? Because you change the space. Gases have more space. Liquid has less. Liquid has less space. So when you compress, distance decreases until it converts into liquid.
Okay.
Are you getting my point?
Yes, sir.
Okay, if you increase the pressure, particles come closer. Their distance decreases. Their distance decreases. As a result, volume of the gas decreases. This is Boyle's law. Are you getting my point or not, Bite?
Sir, on the time.
Me too,
Alhamdulillah,
sir.
Alhamdulillah. Okay. Now, Charles law and KMT. Charles law and kinetic molecular theory. Now, according to kinetic theory, when temperature of the gas, when temperature of the gas increases, gas particles absorb energy. Their velocity increases. Their kinetic energy increases, also increases. As a result, collision of gas particles increases, hence volume also increases. Are you getting this point or not?
Sir,
Yes, Bite?
can you explain what velocity is? I forgot.
Now, you observe that when you boil the water, initially all the water is peaceful. But as the temperature of the liquid increases, liquid particles move very quickly. They move very fast. They collide very fast, which indicates that when you increase the temperature of the liquid, their velocity of the particle increases, their kinetic energy increases, and they
So
get
basically,
the yes.
so basically, it's like speed, yeah.
Sorry.
It's linked.
Eh,
It's linked to speed.
Yes,
The
velocity
velocity.
and speed both are velocity in chemistry. Velocity and speed both are same, or
Okay.
you can say that speed, right? Velocity or
Okay, sir.
in speed both are same. Now, according to me, the first chapter is ended. Now look at the. Can anyone read the topics? These 6 topics, and you can tell me which subtopic is left. Now, anyone? Yes. Anything is left in this chapter? Yes. We have distinguished the properties of the liquid, solid, and gas. And then we have discussed the solid, liquid, and gases, particle separation, arrangement of motion. Now we have completed the change of state, effect of temperature, and interpretation of the heating and cooling curve. Yes. Do you have
No, sir.
any question? Yes.
No, sir.
Now we are moving to its past paper, right? Now we are moving to its past paper. You both are IGCSE?
Yes, sir. I'm.
Okay.
Yes, sir.
Okay. Now states of matter. Here you have kinetic molecule theory. Yes. Yes. This is first question. This is your first question, right? Now, diffusion and kinetic molecular theory. Diffusion and kinetic molecular theory. Now, look at this container. This is a glass tube. This is cotton soaked with HCl. This is cotton soaked with ammonia. Now tell me which gas diffuses more. Yes. You have two gases, HCl and ammonia, NH3. Which gas diffuses more?
Sir, the one with more particles?
The gas which is lighter diffuses
Oh
more.
yeah.
So the first point is gas with lower molecular mass diffuses more. Let's suppose here we have center point. This is center. So can anyone tell me which gas become faster than other? Yes, HCl. Can anyone tell me the mass of hydrogen from the periodic table? Can anyone tell me the mass of hydrogen?
So 1.
1. And chlorine?
35.
Yes, 35.5. So the mass is 36.5. Now NH3. Yes, tell me the mass of nitrogen.
14, sir.
Nitrogen is 14 and you have 3 hydrogen. Hydrogen is 1. So it becomes 17. So which one is lighter?
NH3.
NH3. So NH3 move faster than HCl. So here NH3 and here we have HCl. So this is ammonium chloride, which is the product of reaction of ammonia and HCl. So whenever ammonia reacts with HCl, NH4Cl is formed. So rate of diffusion of NH3 is greater than rate of diffusion of HCl. Why? Because of lighter mass or lower mass. Are you getting my point or not? Bete?
Yes, sir.
Yes, sir.
Okay. Now this is your first question, right? Yes, read this question and give me the answer. Look at the question again. Yes, read the question and give the answer.
Sir, I think it's B.
B. Hmm.
Because no, sorry, it's not B.
Now listen. Now listen, we have beaker, we have nitrogen gas. Can you tell me the molecular mass of nitrogen gas? Nitrogen gas is N2. So N2 means 14 plus 14 is 28. Nitrogen is 28. And this is carbon monoxide. Carbon is 12, oxygen is 16. So it is also 28.
So mass is same,
So mass is same. So here
meaning
we
there's no
have
difference.
atmospheric pressure, right? Gases can diffuse through the porous spot. The diagram shows a beaker full of nitrogen inverted over a porous spot. So the water level does not move. Which statement explain this? Yes, nitrogen is almost
B,
inert.
sir. Then.
A is right or wrong?
Wrong, sir.
A is wrong. B. The two gases have equal molecular masses. Yes.
Yes.
Okay. Yeah, it means 28. Both gases have two atoms in a molecule. It's not the reason. Neither gas is solvent in water. It's not the reason. Okay. Now look at the answer. So the answer is B. Correct. Answer B is correct. Answer B is correct. Now look at this question. Now look at this question. Now this is question number 2. Yes, question number 2. Now look at the question. You have two test tube 1, test tube 2. In test tube 1, you have HCl. In test tube 2, cotton wool soaked in concentrated HCl.
Sir, I know the answer.
You have two tubes, right? Now listen again. Cotton wool soaked in concentrated HCl, and in the second tube, cotton wool soaked in concentrated hydrochloric acid. Both contain blue litmus paper. Now, concentrated hydrochloric acid produces fume of hydrogen chloride. Concentrated hydrobromic acid produces fume of hydrogen bromide. So, in both the liquid, you have in first tube you have HCl, in second tube you have HBr. So, how the gas move through the tube? Yes,
Sir, how can I answer? I can answer.
yes. Tell me, Vidal.
So basically, it says 4 minutes after setting up the experiment, the
Mhm.
litmus in tube one turns red. It means that the hydrochloric acid has a lighter mass than hydrobromic acid, so that's why
Mhm.
diffusion happens more quickly. So the particles travel much quickly as their mass is lighter.
Okay, it took 4 minutes, and here you have 7 minutes. And the reason is molecular mass of HCl. HCl is lower than molecular mass of HBr,
Yes,
right?
sir.
Okay, now look at the answer. Now look at the answer. Yes. This is for the 2 marks. Number 1, diffusion. Molecule moves randomly from the concentration of higher to lower. So this is for 1 mark. different relative molecular mass, they have different molar masses. Okay. So this is for 2 mark, right? So for 1 mark, A1, A2. So A1, you have 2 marks. So you can write any answer, right? So can you tell me the answer again?
Sir, I told the mass, I mean the mass on tube 2 is lighter, so that's why diffusion happens more quickly. The mass
Okay.
of the molecules.
Now the question is that how the gases move through the tube. Question is that how examiner does not ask, right?
Okay.
It did not ask which one turns red, which one move faster. The question was that how the gases move. How the gases move. Are you
Okay,
getting
sir.
my point? Through
Yes, sir.
diffusion. Through
From high
diffusion.
concentration to low concentration.
Exactly. From the
Okay.
region of high concentration, from the region of high concentration to the region of low concentration. From the region of high concentration to the region of low concentration. Are you getting my point or not?
Yes, sir. Getting.
Alhamdulillah. Now next is next question is why the gases take different times to reach the litmus paper. Yes. Anyone give the answer? Can
Sir,
give the answer? Why the gases take different times?
sir, the gases take different times to reach the litmus paper because they have different molecular masses. Uh,
Exactly because their masses are different, right? Why the gases take different time? Because both gases have different molecular mass. Lighter gas moves quickly. Lighter gas move quickly. This is for 1 mark. Next question. Yes. A
Sir, I got
gas
the
range
answer.
is yes, yes. A gas
Uh,
range is filled with 80 cm cube of hydrogen chloride gas at 20 degrees centigrade The syringe is placed in some hot water at 50 degrees centigrade. Now the temperature is increased, right? The atmospheric pressure does not change, but the volume of the gas in the syringe increases. So it's Boyle's law, Charles' law.
Sir, it's Charles law.
Very good. Whenever you increase the temperature, volume,
Increases, sir.
shabash, very good. Very good, very, very good. Now give your answer according to kinetic molecular theory.
Sir,
Yes,
so basically, what happens here? So as temperature increases, volume increases. So when the temperature, when the tube, when the syringe was placed in the water of 50 degrees Celsius, the particles in the tube, the hydrogen chloride particles, they gain energy, and so they started to move faster, and so the volume increased. So so it gained temperature, right? So as temperature increases, volume increases.
okay. Is your answer belongs to the kinetic molecular theory?
Uh, no, I think I missed one point. So basically, when the temperature increases, the particles get more energy, so they move further, so they collide to each other more, and they move further apart. So then the volume increases.
Yes, 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 yes. So when you increase the temperature, right? So molecules move faster. They gain more energy. Their velocity increases. Their kinetic energy increases, right? So they move farther away from each other. Are you getting my point?
Yes, sir.
So you have to include these 2 points. So use the kinetic theory to explain why the volume increases. So this is for 2 marks. As temperature increases, as temperature increases, energy of velocity of the particle, velocity and kinetic energy of the particle increases. Particle increases. This is point number one. This is point number one. As energy increases, as energy increases, collision of particle also increases, gases expand, volume increases, volume increases. Gas expand means their distance increases, particles distance increases. Are you getting my point?
Yes, sir.
Their intermolecular space increases, their distance increases. Now next question. Now next question. Yes. Oh, I'm sorry. Now, with the next question.
Sir, you can't see your screen.
Okay, just a minute. Okay. Yes, this is your question. Yes, tell me the answer. Yes, tell me the answer.
Sir, C, maybe because
C.
sir,
Okay. So, yes, your answer, second student. 16 plus 16 is 32. Yes. Can you give your answer, my dear second student?
Sir,
Yes.
I think B
B. Why B?
was like the molecular mass of Cl2 is greater than O2.
So, the question is that why increases. So, it means in this beaker, you have lighter one. So, which gas has less than 32 mass? The question is that, right? So, molecular mass of carbon dioxide is 44, chlorine is 71, this is 16, and this is 32 plus 14. 32 plus 14 is 46. So, which one is lighter?
C, sir.
C. Because CH4 is lighter than oxygen. Lighter
so
than
why should
oxygen.
sir, why should there be a lighter gas in the beaker?
But if you have the lighter gas, it diffuses more. So if it diffuses more into the porous spot, let's suppose here you have CH4. If it is lighter, then it diffuses rapidly into this. As CH4 diffuses more, this oxygen moves faster. So level rises up.
Okay, sir, I got it.
Okay. Okay. On next class, I will take your test of the same chapter, right? Now, next is 0620 and the paper is H2. This is IGCSE paper 2. Yes, which gas has the fastest rate of diffusion?
Sir, CH4.
CH4. Are you sure?
Sir, H2.
Oh, yeah,
H2.
H2.
Yes, which one is the correct answer? Yes,
Sir, I think, sir, I think A.
A. Why A?
Because H2, the molecular mass will be 2. So, and it is lighter than the others.
Yes, correct answer. I am also with you, right? So A, according to you, correct answer is A. Yes, the answer is correct. Your answer is correct. Now, next question. Yes. Which change of state is in exothermic process? Yes. Which change of state is? Yes. Can you tell me?
Sir, I think condensation.
Yes, sir, it's condensation.
Condensation. Okay. 2. This is 16. This is 44. And this is 32, 64. So the correct answer is A. Now, in next question, which change of state is exothermic? So exo means heat releases. Heat releases when heat releases when solid convert into liquid or liquid convert into solid.
Sir, when liquid turns into a solid, then heat is uh, released.
So it means when gas has more energy. So when gas convert into liquid, energy is released. When liquid convert into solid, energy is released, right? So
Yes,
Yes,
sir.
sir.
gas to liquid is called
Condensation.
gas to liquid is condensation. Liquid to solid is
Sir, freezing.
freezing. So these two are exothermic. These two are exothermic. So which one is correct? Condensation?
Yes.
Okay. So A is correct. Evaporation is liquid to gas. Melting is solid to gas. Sublimation is solid to gas. So last three are endothermic. Okay. So in next class, you have oral test. In next class, you have oral test. Are you are you listening my voice?
Yes, sir. Okay.
In the
Yes,
next
sir.
class, I will take your oral test. Name of the chapter is states of matter, right?
Yes, sir.
Do you have any question? Yes.
No, sir.
No, sir.
Sir, sir.